So, welcome to lecture series on matrix analysis with applications. In the last lecture, we have seen how we can find out rank of a matrix. I have discussed that rank of a matrix is nothing but number of non-zero rows in the echelon form of that matrix, or it is the maximum number of linearly independent rows or columns of the matrix. We have also seen some of the important properties of rank of the matrix. Now, how it is useful to solve system of linear equations, we will see in this lecture. Okay. So, what system of linear equations is, let us see. A system of linear equations is a set of linear equations or a list of linear equations with the same unknowns. Consider the following system of m linear equations with n unknowns. You see, we are having m number of equations. Our equations are linear, having same set of variables x1 to xn, x1 to xn. Okay. So, this system is having n number of unknowns with m equations. So, this here aij's are known, all aij's are known, and the right hand side is also known, and we have to find out xj's, where j is varying from 1 to n. These are the unknowns. Okay. Now, this can also be expressed in the matrix form as follows. You see, if you write Ax equal to b, where A is given by this matrix. Okay, you see, if you see here, the coefficient matrix is A11, A12 up to A1n, A21, A22 up to A2n, and similarly the mth equation AM1, AM2 up to AMN. So, this is the coefficient matrix. This x is x1, x2 up to xn, the unknown vector, and this b is b1, b2 up to bm, this right hand side. So, this A is also called coefficient matrix. This x is called unknown vector, which is to find out. This b is called constant vector or right hand side column vector. So, the matrix representation of a system of linear equation with m unknowns, I mean with n unknowns and m equations, is given by this expression. Now, system of linear equations are of two types. It is either homogeneous or non-homogeneous. What do you mean by homogeneous? You see, if the right hand side, that is this b, if all b's are 0, if b1 equal to 0, b2 equal to 0 up to bm equal to 0, then this system of equations are called homogeneous system. And if there exists at least one bj which is not equal to 0, then this system of equation is called non-homogeneous system of equations. Okay. The system of linear equation Ax equal to b is called consistent if it has one or more than one solutions. System of equations is either consistent or inconsistent. Consistent means it has solution. Solution may be one or maybe more than one. Okay. And inconsistent means no solution. Okay, no solution. Now, a system of linear equation cannot have finitely many, more than one number of solutions. Okay. That means, if you are talking about system of linear equations, whether it is homogeneous or non-homogeneous, there are only three possibilities. The system may either have unique solution, that is only one solution, or it has no solution, okay, or it has infinitely many solutions. It can never have finitely many solutions, that is more than one solutions. Why? You can see here. You have system of equation Ax equal to b, okay, where A is a m cross n matrix, x is a vector which is in Rn, and b is again a vector which is in Rm. Okay. Now, suppose this system has two solutions, x1 and x2. Are the two solutions of Ax equal to b. Okay. Now if x1 and x2 are the two solutions of this means Ax1 equal to b and Ax2 equal to b. If it is a solution, this means it satisfies the system of equations. Now if you take any x bar which is lambda x1 plus 1 minus lambda x2, where lambda is any real number, if you take any x bar which is defined like this, you take Ax bar, then Ax bar will be A of lambda x1 plus 1 minus lambda x2, which can be equal to lambda Ax1 plus 1 minus lambda Ax2. Ax1 is b and Ax2 is also b from here. So, it is lambda into b plus 1 minus lambda into b. So, it is equal to b. So, this implies Ax bar is equal to b. That means x bar is also the solution of the system of linear equation Ax equal to b, and x bar is simply a lambda x1 plus 1 minus lambda x2. So, you vary lambda in R, you will get so many x bar satisfying this equation. So, this equation will be having infinitely many solutions. Okay. So, this system can never be having never have finitely many solutions or more than one solutions. It will be having if it has two solutions, then this means it is having infinitely many solutions. Okay. Now first we will consider how we can find out the solution of homogeneous system of equations. Homogeneous system of equation means the right hand side is 0. Okay. Now the homogeneous system is always consistent. It will never be having no solution. The reason is, if you take Ax equal to 0, so x equal to 0, which is a trivial solution, always satisfies the system of linear equations. So that means the homogeneous system is always consistent. So we have only two possibilities, either it has unique solution or it has infinitely many solutions. Okay. Now how can we say, when we can say that it has unique solution or infinitely many solutions? This unique solution is also called trivial solution, which is 0 solution, x equal to 0, all xi's are 0, and infinitely many solution is also called non-trivial solution, some xi may not be 0. Okay. Now how can we find out whether the system has unique solution or infinitely many solutions? So now we can use the concept of rank. You see, let us consider a matrix of order m cross n such that the rank of matrix is R. Suppose the rank of this matrix is R. Now rank of this matrix is R, what does it mean? It means that this coefficient matrix A are having R number of linearly independent rows or columns, because rank is simply means maximum number of linear independent rows or columns. If the rank is R, this means this matrix is having maximum R number of linearly independent rows or columns. Now here for this coefficient matrix A, number of unknowns are n. Ax equal to b, number of unknowns are n. Now if R is equal to n, that means rank of the matrix is n. N is number of unknowns. That means what? That means, you see, if you are taking Ax equal to 0, the homogeneous system, A is a matrix of order m cross n, and x is x1, x2 up to xn. Okay. Now this system is either having unique solution, as we have discussed, or this system has infinitely many solution. Okay. This is also called trivial solution. This is also called non-trivial solution. Unique solution means x equal to 0. Okay. And infinitely many solution means x not equal to 0, all x are not equal to, all xi's are not equal to 0. Okay. Now, if rank of the matrix is R, rank of A is R. So, there are only two possibilities, either the rank is equal to n, n is number of unknowns, you see, n is number of unknowns. Now, if rank is equal to n, this means this matrix, the rank of this matrix is n, this matrix rank is n. This means the maximum number of linearly independent equation are n, because the rank is n. This means the echelon form of this matrix are having n number of linearly independent rows, and that means we are having n number of linearly independent rows with n number of unknowns. So, it will be having unique solution, and which is the zero solution or trivial solution. Now, if R is less than n, okay, R is either less than n or equal to n, because R is less than minimum or less than equal to minimum of m or n. Okay. So, if R is less than n, this means number of linearly independent equations are less than n, that is unknowns are more than number of linearly independent equations. So, system will be having infinitely many solutions. Okay. So, if R is less than n, infinitely many solutions, that is non-zero solution or non-trivial solution. Now, how to find out all those infinitely many solutions? You see, you can put n minus r variables as arbitrary. You can choose n minus r variables, give arbitrary value to them, and then you can solve the remaining system. Now, let us discuss, let us see a few examples based on this. Suppose you are having this system. Okay. The system of equation is this. The coefficient matrix is what? It is 1 minus 3 7, it is 1 minus 3 7. Second row is 2 minus 1 4, it is 2 minus 1 4. The third row is 1 2 9, 1 2 9. Now, how can we see whether this system has unique solution or infinitely many solution? Because there are only two possibilities, because system is homogeneous. Now, this we can find out calculating the rank of this matrix. So, what is the rank of this matrix? So, what is this coefficient matrix here is? The coefficient matrix here is, you can see, it is 1 minus 3 7, it is 2 minus 1 4, 1 2 9. Now, let us find rank of this matrix, convert this matrix into its echelon form. It is 1 minus 3 7, this minus 2 times this will make 0 here, which is 0, this minus 2 times this will be 5, this minus 2 times this will be 4 minus 14 is minus 10, okay. This minus this is 0, this minus this is 5, this minus this is 2, okay. Now, it is 1 minus 3 7, it is 0 5 minus 10, 0, you will make 0 here with the help of this minus this is 0, this minus this is 12. So, the rank of this matrix is 3, which are number of unknowns. So, this implies unique solution, and unique solution means trivial solution, and trivial solution means x1 equal to, x2 equal to, x3 equal to 0, all x are 0, okay. So, hence we can find out the solution of this system. The next problem, suppose we are having this problem. You see here we are having 4 equations with 3 unknowns, and we have to see whether this system has unique solution or infinitely many solutions. So, you can write the coefficient matrix. The first row is 2 minus 5 8, 2 minus 5 8. The second row is 2 7 minus 1, 2 7 minus 1, and similarly the other 2 rows. When you find out the rank of this matrix, okay, by converting this into its echelon form, so rank we can obtain rank as 2, okay, rank as 2, and number of unknowns are 3. So, rank of matrix is less than number of unknowns. This means this system has infinitely many solutions. Now, how can we find out all those solutions? You can start with this matrix itself. Okay. You can start with this matrix. What is this matrix is? It is 2 minus 5, 8. It is 2 minus 5, 8. It is 0 and then 12, 9. 12 minus 9 and 0, 0, 0, 0, 0, 0. We are having x1, x2, x3 and it is 0, 0, 0. So, the first linearly independent equation we are having is this equation. The second linear independent equation we are having as this equation. So, you can arbitrarily choose. We are having two equations, linear independent equation, 3 unknowns. So, 3 minus 2 is 1. So, we can put one of the variable as give arbitrary value to it and find out the values of other two variables. So, let x3 equal to t. So, you can find x2. x2 will be simply 3 by 4 times t from here, and you can substitute x3 and x2 in this equation and find x1. So, here t is any real number, okay, arbitrary value. So, in this way we can find out x1, x2 and x3. So, now let us solve these two problems. What are conditions on A and B such that the system of linear equation this has unique solution or infinitely many solutions? We have to find out the conditions on A and B such that this system has unique solution or infinitely many solutions. So, let us try this problem now. Now, what is the coefficient matrix here? The coefficient matrix is it's 1, 2, 3, it's 1, minus 1, minus 2a and it is 2b, 6. This is the coefficient matrix. Now, to find the conditions on A and B for which this system has unique solution or infinitely many solutions, we first find out the echelon form of this matrix. Okay. And then we can impose the condition on A that when the rank of the matrix is equal to 3, because if rank of the matrix is 3, this means is equal to number of unknowns, this means unique solution, and then when the rank of the matrix is less than 3, in that case it is having infinitely many solutions. So, first let us try to find out the echelon form of this matrix. So, you see it is 1, 2, 3 will remain the same. You will make 0 here with the help of this. So, it is simply this plus this plus this is 0. The same operation you will apply on the entire row. This plus this is 0, this plus this is a plus 3. You will make 0 here with the help of the first row. So, this minus 2 times this will make 0 here, 0. This minus 2 times this will be b minus 4. This minus 2 times this will be 0. Okay. Now, it is a 0 element. It is a 0 element. So, it is better to interchange these two rows. This element may or may not be 0, depends on the value of b, but this is always 0. So, better to interchange these two rows to find out the echelon form of this matrix. So, it is 1, 2, 3, it is 0, b minus 4, it is 0, it is 0, 0, a plus 3. We have interchanged these two rows. Now, for unique solution. For unique solution, rank of A must be equal to number of unknowns. Number of unknowns here are 3. So, rank of A must be 3. Rank of A 3 means for this 3 cross 3 matrix, rank will be 3. That means there is no row containing all 0. So, this must be non-zero and this also must be non-zero. Then only this row will not be 0 and this row will not be 0. If any one becomes 0, then the rank will be less than 3. So, this implies A should not equal to minus 3 and B should not equal to 4. Then only rank of this matrix will be 3. So, for unique solution we are having these two conditions. Now, for many solutions, infinitely many solutions, rank of A must be less than 3. Now, rank of A is less than 3. That means there exists at least one row containing all 0 elements. So, this may be having that this is 0, this is not equal to 0, this is 0, this is not equal to 0, or both of them are 0. So, we can write either A equal to minus 3 or B equal to 4 or both. Then the rank of this matrix will be less than 3. If both are conditions satisfied, the rank is 1. If one of the conditions satisfied, the rank is 2. In both the cases, the system is having infinitely many solutions. Okay. Now, similarly, if you try to find out this system, then how can we solve this system? Let us see. What is the coefficient matrix here? Coefficient matrix here is minus 1 0 2. It is 2 lambda 4. It is 1 mu 1. Okay. So, first find the echelon form of this matrix again. So, leave this row as it is. This plus 2 times this is 0, this plus 2 times this is lambda, this plus 2 times this is 8. This plus this is 0, this plus this is mu, this plus this is 3. Okay. Now, we have to find out the condition. Okay. Now, if I want to make 0 here with the help of this, so this lambda may or may not be 0. So, I have to take two conditions basically. So, basically if lambda equal to 0, then matrix A will be, the echelon form will be this 0 2 0 0 8 0 mu 3, and this will be minus 1 0 2. You can interchange these two rows, 0 mu 3 0 0 8. Now, this will be having unique solution if rank of this matrix is 3, and rank of this matrix will be 3 when mu is not equal to 0, then only rank will be 3. Okay. So, mu should not equal to 0, and for many solutions rank mu should be 0, because if mu is 0, so you can make 0 here with the help of this. So, rank will become 2, and if mu is not equal to 0, so rank will be 3. Okay. So, one condition is over. Now, if lambda is not equal to 0, then it will be minus 1 0 2 0 lambda 8 0 mu 3. Now, you can apply one row operation here. You can replace R3 by R3 minus mu by lambda times R2. So, what you will obtain? It is minus 1 0 2, it is 0 lambda 8, it is 0 0, it is 3 minus mu by lambda times 8, because we want to convert this into its echelon form. Now, for unique solution, how will you get the unique solution? If rank of this matrix is 3, number of unknowns, and rank will be 3 if lambda is not equal to 0 and this is not equal to 0. Rank lambda is not equal to 0 is already there, so we do not need this condition. So, 3 minus mu upon lambda into 8 should not be 0. So, this implies 3 lambda should not equal to 8 mu. And for many solution, in this case, this must be 0, because we want rank less than 3. Okay. So, 3 minus mu upon lambda into 8 must be 0. So, this implies 3 lambda should be 8 mu. Now, if lambda equal to 0, the first condition, if lambda equal to 0, you see, for unique solution mu should not equal to 0. If you substitute it here, lambda equal to 0, then mu is not equal to 0. That is coming from this condition itself. And if lambda equal to 0, for many solution mu should be 0. That is coming from here. So we can combine these two conditions and we can simply say that for unique solution 3 lambda should not equal to 8 mu, and for many solution, infinitely many solution, 3 lambda should be equal to 8 mu. So in this way we can find out the conditions on lambda and mu such that the system of equations are having unique solution, infinitely many solutions. Okay. So in this lecture we have seen that how can we solve homogeneous system of equations using the rank approach. You find the rank of the matrix. If you see that rank of the matrix is equal to number of unknowns, this means system is having, the homogeneous system is having unique solution. If rank of matrix is less than n, less than number of unknowns, this means system is having infinitely many solutions. In the next lecture we will see that how can we solve system of non-homogeneous equations. Okay. So thank you.